So today I'll be talking about my part in the VLE analysis of water and organic mixtures. I'm Mike Daguilar, and so I'll be starting. Nancy already went over our introduction, so I'll be going straight into my part, which was water and ethanol. Water methanol. So here on the VLE plot, we see two curves, one for the liquid composition and one for the vapor composition. The main thing to notice is that the vapor curve shifts strongly towards methanol. This happens because methanol is more volatile than water, so the vapor phase always ends up like in a richer methanol compared to like the liquid. For the bubble point, I started with a liquid mixture that was like 50% water and 50% methanol. The bubble point temperature came out about 24.1 Celsius. This is the temperature where the liquid mixture first starts to boil and a tiny amount of vapor forms. At this point, the vapor that forms is mostly methanol, about 84% methanol and 60% water. This also shows like the methanol's higher volatility, because even when the liquid is 50-50, the vapor that forms is strongly methanol rich. For the dew point, I used a vapor mixture that was 50% methanol and 50% water again. The dew point temperature was a little bit more higher, but 82.8% Celsius. This temperature is where the vapor first starts to condense, and once it does, the liquid that forms is almost all about water, like 96% water and 4% methanol. This makes sense because methanol likes to stay in the vapor phase, so first liquid that condenses is mostly water. And overall, like the bubble point and dew point results match the plot pretty well. Just because they show that methanol is more volatile, like the component, and the vapor phase is always methanol rich, and the liquid phase always is water rich. And so this is like a kind of behavior like it looks for a water organic system like water methanol. And that's me talking about the bubble point and dew point. Thank you.